Paul Harvey, famous commentator, once said that if there is a 50-50 probability that something will go wrong, then 9 out of 10 times it will, which actually doesn't make any sense because it should only be 1 out of 2 times. So anyways, we're going to go ahead and look at conditional probability. We're also going to look at the words and or, and so this part we're looking at intersections and unions. So I have my drawing here with a trapezoid, a shaded triangle, a circle, and a square, and it's all inside of this rectangle, and I'm assuming that my point will fall in the rectangle. So what is the probability it will be in the circle? Okay, well, I need to go ahead, if you remember from geometric probability, I need to find the area of the circle. So I do this area over the total area, and that will give me the probability. Well, area of the circle is pi r squared, and since the vertex of the square is in the center, then I know this edge of the square is a radius. Well, this edge is 3. All sides are congruent on a square, so that edge is 3, which means the radius is 3. So the area of the circle is pi times 3 squared, or 9 pi inches squared. And the total area is pretty straightforward because it's just a rectangle. It's going to be 8 times 15, or 120 inches squared. So to calculate the probability, I'm going to take that 9 pi and that 120 and put them over each other. So 9 pi divided by 120, if I want to put this in an approximation, is 24 hundredths, 0.24. That's after rounding. So what is the probability it'll be in the square? Well, I would expect this probability to be smaller than the probability for the circle because you can see the area is smaller. So I still have to find the area of the square. I already know the area of the total is 120. So area of the square is side squared, which is just 3 squared, or 9. And the area of the total we already know is 120. So 9 divided by 120 is 0.075, or 0.08 if I round to the hundredths. So this probability that's in the square is smaller than it is in the circle, and that makes sense. Now I'm going to find the probability that the point would be in the square and the circle at the same time. So where is that? So you see this area I've shaded, that all this that's in yellow is in the square and in the circle at the same time. You could almost think of it as where they overlap. This is also called the intersection of the circle and the square. So we're going to go ahead and calculate this area to the hundredths. So this intersection is just 1/4 of the circle. You almost have to reason that one out. There's nothing that says, oh, you're just going to do 1/4 of a circle. You can look at it and see that this area is actually 1/4 of the circle. So it's pi r squared, in this case 3 squared, all over 4. Or it's going to be 9 pi over 4, and you get your calculator, and this area is 7 and 0.07, or 7 7/100ths of an inch squared. So what is the probability that a point randomly picked will be both in the square and the circle? We're still using the same model. We're doing area of the intersection over the total area. So I take that 7.07 and divide it by 120, which gives me 0.06 after rounding, or 6 hundredths. So this probability is quite small. And in fact, if I list the probabilities in ascending order, that means from smallest to largest, the smallest one is the intersection, when it's in the circle and the square at the same time. So when two things have to happen and you hear the word and, that usually limits where it can be. It doesn't make it bigger. Some people might say, oh, you want to add them. No, you actually have to go and see where they overlap and look at the intersection. Probability of the square, since the square is a little larger than the area, the probability is a little larger. And the probability of the circle is the largest of them all. And you can kind of tell that it's the largest. So now we're going to go ahead and look at the union of the circle and the square, where they are combined. And that's going to be this area here. This is called the union. So we use this symbol, it looks like a U, of the circle and the square. When we put them together, and we don't double count. So it's not like I'm taking a square, all the square area, and just adding it to the circle area. So it's a little more complicated because I just need this piece. So I could say a circle plus this piece. The easier way to do that, though, is I could see that I've got a square plus 3/4 of a circle. And that one I'm very good at doing. So that's just going to be 3 squared plus 3/4 of the circle, pi times 3 squared, or 9 plus 27 over 4 pi. So the area is 30.2 inches squared. So what's the probability that a point randomly picked is going to be in the circle or the square? Well, that's going to be this union of pieces here. So I'm going to find that area over the total. Well, we just calculated that it's 30.2 or 120 inches squared. So when I divide that, I get 25 hundredths, 0.25. And that makes sense that this probability would actually be bigger than either the probability of a circle or probability of a square, because the union, the or, is putting everything together. So what does and mean in probability? Can probability of A and B, they intersect and B, ever be larger than probability of A or B? I have the feeling that a lot of times people are going to think probability of A and B is going to be bigger, but that's not what the and means. It's an intersection. It's where they overlap. So it tends to be the smallest of the probabilities, which will always be the largest. The probability of A, the probability of B, the probability of A and B, or the probability of A or B. And why? Well, we just said the probability of A and B is going to be the smallest because it's the intersection where they overlap. The union, on the other hand, takes all the pieces from A and all the other pieces from B, and what they put them together and they take out the overlap, but only not to double count it. So the overlap's still there, just one time. So that's actually always going to be the largest. So remember, what is the difference between and or? Believe it or not, and sounds like it's going to be bigger, but it's not. And or sounds like it would be smaller, but it's not.